What's up, guys, and welcome to the explanations for the Chapter 8 test. Let's do it. Alright, question 1. Is the relation a function? So a function just means that the way that I think about it is there's no x's that are matching with more than one y. So the way we say it is the y's can cheat on the x's, but the x's can't cheat on the y's. So I would say, since there's a unique x in every single one of these, it is a function. Every x has only one corresponding y value. And this would be the wrong explanation. Now, if I, for example, added another coordinate like 2, 2, then this would no longer be a function, because then we'd have a repeat of 2 pairing with 3 and 2 pairing with 2. So that is the answer there. All right, next question. Find the 10th term of the missing sequence. So we got 1, 8, 15, 22. The question is, how is this sequence growing? That's what we have to figure out. Well, it looks like an arithmetic sequence, and it looks like it's just going up by 7 each time. You have to identify a pattern that gets you to each successive term without changing, and plus 7 works every single time. So the next term in the sequence, I'm sorry, the 10th term in the sequence. So we could kind of figure it out like this. We could sort of keep going. Now, what you could also do is there is a formula. It's a to the n equals a to the sub 1, which is the first term, plus the difference times n minus 1. Okay, I'm going to explain what all this means. So basically all we're doing is we're taking the first term, that's a sub 1. The difference is the 7 value, right? It's how much each term is different by going up. And n minus 1 is what? N is the number, the term that we're trying to find, right? Like in this case, we're trying to find the 10th term. So it'd be a1, which is 1, plus d, which is 7, times 10 minus 1. So this is 7 times 9. This is 63 plus 1 equals 64. Now we could also carry this out a different way. Let's just make sure it's there. Yeah, 64 is there. We could also carry it out another way, and we could kind of verify that this is indeed the 10th term. So the next term would be 29, right? That's the 5th term. The 6th term would be 36. 7th term would be 43. 8th term would be 50, 57, and 64. So you could also do it that way as well. All right, question number 3. Using the table below, describe the relationship between the side length and the perimeter of a regular pentagon. Use the variables s and p to write an equation. So we could say that the perimeter in this case equals side length, which is these values. And what's happening? How are we going from side length to perimeter? What does it look like is happening? Plus 4 doesn't work because that's plus 4, but that would be plus 8. So it must be a multiplier. What about times 5? 1 times 5 is 5, 2 times 5 is 10. Now we found our common multiplier, and it's p equals, perimeter equals literally 5 times s. That's what we've shown. Yeah, it's right here. Find 4 solutions to the equation. So you could plug anything in here really and make sure you get the right y values, but let's check and kind of go down the line and see which one of these options fits. 1, 4 does right off the bat, that doesn't work. You plug 1 in, you get 2. 2 minus 5 is negative 3. That's out. 0, negative 5, yes, that works. 1, 5, nope, that's out, because 1 you should be getting negative 3. 0, negative 5, yes, that's fine. 1, negative 3, yes. 2, 0, no. Because you plug in 2, you get 4 minus 5, which is negative 1, so that doesn't work. This one's got to be the right answer, and I'll actually write them out now. So here, first we're plugging in negative 4 for x. We should get 13, that's negative 8 minus 5. And we get negative 13, and that's what they show right here. Now let's plug in negative 3. We should be getting negative 11. It's negative 6 minus 5, negative 11, yes. Let's plug in negative 2, 2 times negative 2 minus 5, which is negative 4 minus 5, which is negative 9, and that's what they show here, negative 2, negative 9. And then negative 1 negative 2 minus 5, which is negative 7. And that works too. That's our answer. Okay, next question. Find 4 solutions to this guy. Same deal. So we're going to kind of jump through 0, 0, 0, negative 6, yes. Let's see, 1, negative 9. This one's out also. When we get to the right one, I'm going to show you how it works. No. It's got to be the last one again. Okay, so let's try it. So 0, negative 6, if we plug in 0, we get negative 3 times 2, which is negative 6, and that's right. Now it's 1, negative 9. And indeed, we're going to get negative 9 there. Now it's 2, negative 12. Okay, 2 plus 2 is 4. Negative 12. And then 3. Negative 3 times 3 plus 2. And negative 15. And there we go. The last one is good. Next. Question 6. Find 4 solutions to this guy. So remember, look, x is just going to be y plus 3. So, or whatever we plug in for y, x is going to be 3 greater. That's it. This is out because we have, oh wait, no, hold on, this isn't out. If y is negative 7, it would be negative 4. Y is negative 5, it would be negative 2. Yeah, the x is always 3 greater. This one's correct. In this case, this is wrong. The y is 3 greater. The y is 3 greater. And it's not right. So it's just that top one. All right, which graph represents the following equation? So we got y equals negative x plus 6. Let's think about this. So in slope-intercept form, which is what this is in, it's plus 6. We've got a slope of negative 1. And here's my y-intercept, right? We got a y-intercept of 6. So we need to have an equation where we're hitting the y-axis at 6. We got a slope of negative 1. This is not a slope of negative 1. This is a slope of positive 1. It's going up 1 over 1, up 1 over 1. So it's almost there. Y-intercept of 6, slope of negative 1, going down 1 over 1, down. This is a negative 1 slope. It's going down by 1 over by 1. Because really a slope of negative 1 is negative 1 over 1. So it's going down 1 to the right 1. This one's good. Let's check the rest of these guys. This slope is off. This is a slope of negative 1/2, negative 1 over 2, negative 1 over 2. And this is positive, so that's out. All right, question number 8. Which of the graphs represents the following equation? So if we look again in terms of slope-intercept form, there's no y-intercept, which means the y-intercept is 0. And the slope is 3, which is really 3 over 1. It means we're going up 3 over 1, up 3 over 1. So let's see which one of these has the right set. This is the wrong y-intercept. It's hitting it at 3. It's the wrong y-intercept. All these are this is the right y-intercept. It's hitting it at 0. And it's going up by 3 over by 1, up by 3 over by 1. This is the right slope. So here's our answer. We can just look at the last one quickly. This is a slope of 1/3, not 3 over 1, because it's going, we always do rise first. It's going up by 1 over 3, up by 1 over 3. So this guy's our answer right here. Okay, question number 9. Which of the following graphs represents the following equation? This is a tricky one because this is just x equals 5. Where's the y? How do we handle this? Okay, the way I think about these types of lines, this is either a vertical or a horizontal line. So we want to think about it like this. Well, let's say this is 5 on the x-axis. This is negative 5. This is negative 5 down here. 5. Let me approach it this way. When y equals 0, what does x equal? X equals 5. When y equals 5, what does x equal? X equals 5. Y equals negative 5, what does x equal? 5. X always equals 5. Therefore, it's going to look like this, and it's a vertical line. So we should be looking for a vertical line, not a horizontal line. Vertical line at 5, just like this guy. And that's it. Question number 10. Which of the graphs represents the following equation y equals 4? Actually, I'm not going to erase this now. I'm going to do the exact same example, but for this line. So now I'm going to ask you, I'm going to ask what happens when x equals 0? Y equals 4. What happens when x equals 5? Y equals 4. Y equals 4, right? So y is always equaling 4. When y equals a number, now it's a horizontal line, right at 4. So let's see where it is. This is it right here. Okay. Boom. Next question. Farmer John is curious about how many eggs his chickens lay every day. The graph shows a relationship between the number of eggs that are laid each day and the number of chickens. What is the rate of change for the linear function shown in the graph? Okay. So let's see. The rate of change is when we have 4 eggs. Be very careful of these numbers, right? Because they're different scaling on the top, on the x and the y. So we have 4 eggs for every 2 chickens, right? Or we could say 2 eggs for every 1 chicken. 2 eggs for every 1 chicken. And that's basically it. 2 over 1. 2 eggs per chicken, right here. Right? Rise going up by 2 eggs, over run going over by 1 chicken, up 2 over 1, and that's it. State the slope and y-intercept of the equation graph below. What is the y-intercept? It's right here. -6 is right where it hits the y-axis. That's your y-intercept. What's my slope for this equation? It's going, let's find 2 good points. I see a nice point here where it hits exactly in the crosshairs and right here. So to go from here to here, we could choose any 2 points, but it's just going to be harder with different points. So to get from here to here, we go up by 8, right? 8 plus -6 is 2. And we go over by 2. So the rise is 8, the run is 2, which reduces to 4. So it's got a slope of 4. Right here, this guy, and a y-intercept of -6. And all these y-intercepts were wrong, so we could already eliminate on that basis. Okay. Now, to state the slope and y-intercept here, we need to isolate. So we need to get y by itself. So 4y plus 2x equals 4. Now I'm going to subtract 2x, subtract 2x. We've got 4y equals -2x plus 4. Divide both sides by 4, and we get y equals -2x over 4 plus 4 over 4, which reduces to 1, and this reduces, and this reduces to -1/2 x. Right, 2 over 4 is -1/2 equals y. My y-intercept is 1. My slope is -1/2. That's it. Y-intercept is 1, slope is -1/2. The total profit for a disco party at the roller rink varies directly with the number of tickets sold. Suppose the roller rink earns $75.80, excuse me. $75.80 if 20 tickets are sold. Which of the following these equations could represent the profit per ticket sold? Okay. So it would be mx, and then they're saying there's some slope here that we need to find, and there's x is going to be the number of tickets. So, oh, well, actually, you know what? Let's do it like this. Number of tickets sold. Let's make it t. Okay. So basically, they're saying p equals m, or whatever, the rate times t. But we have to solve for this m value. And the way we do that is we know that it's $75.80 when t equals 20. So now to get this per ticket cost, we gotta divide by 20. So $75.80 divided by 20 is 7.58, which is, and then half of that, I'm just trying to kind of do this mentally, you can use a calculator for this type of a problem, 3.79. So $3.79. So the equation should be P equals 379 times t. Here we go. No y-intercept, and that's it. The total profit for a disco party varies directly with the number of tickets sold. So suppose that the roller rink in 70, so same situation. Find the profit if 99 tickets are sold. Actually, I'm going to bring this back. So we're going to come back to this equation right here. And we need to find the profit if 99 tickets are sold. Just plug t in, 99 in for t. Now, here's my simple way of doing this. This is almost the same as multiplying by 100, which is 379. And then take 379 away. This is just a fast way to do it, like this. So 8, 10, 9, 10. So it's 1, 2, 5, 7, 3. 375, 21. There it is. All right. A fisherman catches 20 fish per day plus an additional 5 fish every time he spots a mermaid, because everyone knows that mermaids are lucky. Which of these equations could represent the number of fish the fisherman catches each day? Let F equal number of fish caught and M equal number of mermaids spotted. This is it. 20 fish, no matter what, per day, and that's your y-intercept, that's where we're starting at, plus 5 fish per every mermaid. This is like 5 is kind of like the slope, and mermaids is, you know, it's essentially the rate of change. And then mermaids, each mermaid, we're gonna add additional 5. It's right there, that first one. Question 17, a fisherman catches 20 fish per day, so it's the same situation. So it's fish equals 20 plus 5m. How many will he catch in a day if he finds a family of 4 mermaids glistening in the sun? 4 plugs in for mermaids. 20 plus 20, which equals 40. All right, 18. The Majestic California redwood is the tallest tree in the whole world. The graph below represents how tall the redwood is versus its age. Which of the following equations could represent the graph? Okay. So we've got something like this. It looks like a y-intercept of 10. And it looks like it's going up. Let's look at these 2 points. It's going up by 165. And it's going over by 3. That's the slope right there. And this is indeed divisible. It's 55. Wait, hold on. Yeah, 55. 50. This reduces to just 55. So it's a slope of 55. It should be a slope of 55. And the plus the y-intercept of 10. So that should be our equation. And they just have A for y. And oh no, actually A is not y. It should be height for y. Height for y and A for age. Should be something like this. This guy right here. Cool. Question 19. The Majestic, so same, oops, let me keep that equation up here. I think it's the same thing. What does the slope of the line represent? The slope of the line represents the change. It represents the change in height over each year. Basically, how much this tree is growing every year. It's growing 55 feet each year, and that's it, 55 feet. Slope represents how much the redwood will grow per year, just like we said, right? Change. All right, find the slope of the line that passes through the following pair of points. How do we find the slope? Well, here's how I always do it. I stack the coordinates 3, 4 over 5, 6. And then I take the difference. It's the difference of the y, so I subtract down 4 minus 6 over the difference of the x's. It's got to be in this order. That's why I stack them, 3 minus 5. And we get -2 over -2, which is a positive slope of 1. There we go. Question 21. Same idea. 12, 2. over 4, negative 4. Subtract down 2 minus negative 4 over 12 minus 4. This is on top becomes a plus, so it's 6 over 8, which reduces to 3/4. Question 22. The graph below represents the expected future population on Mars. Use the line of fit to predict what the Mars population will be in 2056. This is the line of best fit, right? The line of fit, and it's basically tries to be the exact average of all of these points. It's used to predict, right? We're trying to find a nice line that models what we see, where we see these points, these actual data points being distributed. So what will the Mars population be in 2056? Well, let's find 2056 right here. We're gonna find that point on the line, and it looks like, I don't know, 1490, 1480 maybe? Let's see, 1470, that's our closest one. I'd say that's pretty good. Yeah, all right, cool. Which of the following graphs represents the system below? All right. So y equals negative 2. First of all, I'm gonna get the second one in slope-intercept form. So, oops. So we got 2y equals x, divide both sides by 2. And we got y equals, this is really just 1/2 x, or x over 2. I'll write it like this so then we can see that the slope is 1/2. The second line has a y-intercept of 0, no y-intercept. And this one has a y-intercept of 5. So on that basis, these are correct in terms of we got a slope of 5, we got a y-intercept of 5, and we got a y-intercept of 0. We got a slope of, this should have a slope of negative 2, let's see. It goes down by 5, oh wait, down by 5, over by 3. This doesn't look exactly right, it's close. This is not a slope of negative 2. And this does this is a slope of 1/2, up by 4, over 2. Yeah, oh no, this isn't a slope of 1/2, this is a slope of 2, so this is out. Let me write this other line down. Y equals negative 2x plus 5. Okay. 0 and 5, y-intercepts are correct. So this is 1/2 x, up by 1 over by 2, up by 1 over by 2. This is good, and then a slope of negative 2, let's see, down by 2. This looks okay. Down by 2 over by 1. So let's see, 5 to 1, we're dropping by 4. So that's negative 4 over positive 2. This one looks good. I'm gonna select it, but let's look at the, oops. Let's look at the other ones. This is off, these are off, okay. It has to be this guy. All right, 24. Solve the system of equations. So we got y equals 8x plus 20. We got y equals negative 4. We have two things that equal y. Let's just substitute, right? I'm going to substitute in negative 4 for y. So now let's solve this equation. We can solve for x. 8x, no, sorry, let's actually subtract 20. Subtract 20 from both sides. 8x equals negative 24, divide by 8, divide by 8. X equals negative 3. And if my x equals negative 3, we know the y equals negative 4. I mean, it doesn't matter, you plug it in here, but y always equals negative 4 for this guy. So our solution set is negative 3, negative 4. We're just trying to find the point of intersection. That's what we found. 25. So we're doing the same thing here. Now, this is a little different. But what we're going to do here is we're going to do some, let's see, what should I do? Substitution. Yeah, I'm going to do substitution. So I'm going to say, since y equals 3x minus 5, I'm going to plug that into my equation down here. X equals 1/3 y. This is called substitution. So I see that y equals this here. Well, and then I'm going to say, well, okay, I'm going to replace the y down here with this because I'm trying to find the one point where these two are equivalent. So this is totally allowed. And so now I'm substituting this piece in for y because it equals y. So 1/3, so I'm replacing the y with 3x minus 5 plus 5/3. Let's distribute this here and here. X equals 1/3 times 3 is just 1, so x minus 5/3 plus 5/3. These guys cancel out. Oh, wait a minute, I get x equals x. So what does that mean? That means that these two lines must actually be the same. There must be infinite solutions. So this is it. Infinitely many solutions. If you ever solve a system of equations, you get something like this, like x equals x or 1 equals 1 or something like that. Whatever it is, you know it has infinite solutions. All right. Now we need to lastly determine whether this has no solution, many solutions, or one solution. If it has one solution, what is the solution? Okay. So I'm going to do a little substitution again. We got y equals, so I'm going to set them both equal to each other because this is y and this is y. I'm going to replace this y with this guy. 5x plus 3 equals 5x plus 7. Subtract 5x from both sides. Now you see what's happened. The x's are completely gone, but we are left with this bizarre answer, 3 equals 7, which is patently false. Now if you ever get an answer like this, like before we had 3 equals 3 or 5 equals 5 or x equals x, that means there's infinite solutions. When we get 3 equals 7, it means there's no solution because this is an absurd answer. And so we say no solution. All right, so that is it for the explanations for the Chapter 8 test. Time to move on to the next section.